When we work with geometry, we're going to run into several situations where we have parallel lines that are cut by what we call a transversal. So if you look up here in my top left corner, I have this statement that says J is parallel to K. What that tells me is that these two lines right here are running parallel to each other. Why that's important is because when I cut them with a transversal, and a transversal is just a line that cuts across another line, I have some unique things start to pop up with the angles that are involved. So if you look at the situation I have here, I have one angle, my 32, and then I have some missing angles that I'm going to be trying to find. Now, since these are parallel lines cut by a transversal, I have some interesting things. First of all, our opposite angles are always going to be the same. So 32 is going to be there, and I also have it here because these angles form, since they're opposite from each other, are the exact same angle. Now, on the flip side of that, I also have this large angle right here who has an opposite right here that's exactly the same. So within each little kind of intersection point, we have four angles, which are really just two of the same ones that repeat. So I have two 32s, and then I have two of these blue angles as well. Now, say I wanted to find what this blue angle was. Well, I know that I have an interesting situation popping up here because these two angles are what we call supplementary angles, which means they add up to 180 degrees. So I can know that I have 180 total. Let me take away the 32 that I already have over here, and that's going to leave me with what's left over. So if I do my subtraction, that's going to leave me with 148 degrees. So I have 148 degrees here. I also have 148 degrees here. So notice now I have two angles, but that pop up and they have a partner right kind of across from each other. So that's what, when I say across, I mean across from that intersection point. Now, these over here, so great, we figured out this side, but what about over here? Well, again, that's where we run into the unique part about parallel and transversal lines. Because since J and K are parallel, whatever happens at one intersection happens at the other intersection as well. So I'm going to mark here, these two red angles are the same, and these blue angles here are the same as well. So once I find one, I know where they're at all the way across the board. So these blues are both 148, just like at the other intersection, and these red ones are both 32s, just like at the other intersection. So really, whenever we have two parallel lines, my J and my K, that are cut by a transversal, we only have two different angle measurements that are going to appear 4 times each. And that's always true. So knowing that, I can use that to set up different equations, to solve for things, as long as we know those rules. So the big thing to get out of it: angles that are across from each other. And when I say across from each other, remember I mean across from that intersection point. So like my two blues and my two reds. If they're across from each other, they're the same. Also with one of these, you can kind of trust your eyes. My big angles over here are going to match my big angles over on the other side as well. So that's kind of the key things we need to get when we're looking at parallel and transversals.